Hello and welcome to the second video in our lecture on the weaknesses of public key cryptosystems. In a previous video, we compared public key cryptosystems and symmetric ones in terms of applicability. In this video, we're going to dig a little bit deeper into the pros and cons of both approaches. So, on the one hand, we have public key cryptosystems, and on the other hand, we have symmetric cryptosystems. And we're going to discuss the pros and cons of each approach. And since they are the flip side of each other, I'm going to list the cons here before the pros. Okay. So remember that the conclusion of the previous video was that one of the advantages of symmetric crypto system was that they were fast, in fact, much faster than the public key crypto systems. So why are we not using symmetric key crypto systems only and forget about public key crypto systems? Well, that's because symmetric ones have a major weakness, which is the need for the two parties to share a private key. And so somehow that key has to be distributed among the two parties prior to establishing and using the secure channel. So the main con here for symmetric crypto system is the need for a private key distribution system. So the problem here is the private key distribution problem. If you have a secure way of distributing the keys, then maybe you would have no reason to use a private key crypto system, since if you can share the keys privately, why wouldn't you be able to share the messages? So we already discussed this problem before, and one answer to that problem was the Diffie-Hellman algorithm. But on the flip side then, the public key crypto systems, they do not have this problem of private key distribution. And the reason they do not have this problem is because they do not need to share any private key. Remember that every party has its own private key and does not need to share it with anybody else. All right. Now, as it turns out, public key crypto systems have a different problem, which is they don't need to share a private key, but they do need to share public keys. That's the flip side of the approach. And it turns out, even though you may not have thought about it and we haven't discussed it yet, sharing the public key is not as easy as it seems. So one of the cons of the public key crypto system is the public key distribution problem. And the way that this is usually solved is using what's called a public key infrastructure, or PKI. And this is a pretty significant piece of the puzzle. And as I said, sharing the public keys is actually a pretty major problem that is not completely solved to this day. So on the flip side then, one of the pros of the symmetric cryptographic system is that they have no need for a PKI, a public key infrastructure. Why? Because they are not sharing any public keys. So you see, if you look at this table, you'll notice that public key crypto systems and symmetric crypto systems have complementary pros and cons, and no one approach is completely better than the other. So the next obvious question is, can we get the best of both worlds? And the answer is yes, a qualified yes anyway, and this is basically the way current systems work. These are called hybrid crypto systems. They're hybrid because they use both aspects or both aspects of both approaches, public key and symmetric. So what is a hybrid crypto system? Well, in the first stage, a hybrid crypto system is going to use public key crypto to generate shared private key. So to generate a shared private key. So an example of this type of application is the Diffie-Hellman algorithm that you can use between two parties for them to securely come to an agreement on a shared private key. Then once they have that key, they can use a symmetric crypto system with that private key. Okay, so hybrid crypto systems take advantage of both approaches. First, they use public key cryptography, which is slow, but it's okay because we're not using it to encrypt whole communications. We're only using it as a preliminary step to agree on a shared private key. And then they use this shared private key in a fast, symmetric way of doing encryption and decryption. So here is a simple protocol that uses a similar idea of a hybrid crypto system. Notice that Alice and Bob want to communicate using confidential messages. So Alice is going to pick a random bit string that she will call K, and she will encrypt that key K using the public key of Bob, the recipient. So this is a use of public key cryptography. And because she encrypted that key that she chose using the public key of Bob, only Bob is going to be able to decrypt it. So this is like step number one. Alice and Bob now are the only two people who know that key, assuming Alice has not shared it with anyone. Then, so this is step number one. Then in step number two, Alice and Bob can use that key to encrypt data in their back and forth communications. So you see, this is a very simplified way of applying a hybrid crypto system to do a one-time slow operation to share a public key, sorry, a private key, and then use a fast encryption decryption algorithm for the remainder of the session to encrypt all of the messages between the two parties. So of course, this uh, hybrid crypto system that is shown on this slide is a very simple one. So the next question is this protocol secure? And to answer this question, I want you to think about both confidentiality and integrity and non-repudiation and authentication and so on and so forth. So please pause the video and think about answering this question about the security of this protocol. When you come back, we'll discuss some answers. So hopefully you took your time to think about this simple protocol, and the answer is, in some respect, this protocol is not secure at all. And one of the main weaknesses of it has to do with authentication. So in case you did not think about this yet, think about whether in this communication protocol, Alice is authenticated. And then think about whether Bob is authenticated. In other words, from the perspective of Alice, is she sure that she's actually talking to Bob? So is Bob authenticated as far as Alice is concerned? And vice versa, when Bob is talking to Alice, is he sure that Alice is the person on the other end? So you should notice when you think about this aspect that this protocol is not secure when it comes to authentication. So the bottom line is that hybrid crypto systems are a nice way to combine the advantages of both public key and symmetric crypto systems, but as always in cryptography, there are a lot of subtleties, and such simple protocols are not considered secure.